as a result of our observations, we're going to come up with a table where we have ramp slope and cart acceleration. We'll have 4 different slopes, 4 different accelerations. And then we'll be able to put these in a graph of cart acceleration versus ramp slope. The cart acceleration will probably be measured in centimeters per second. And we'll have 4 points. Actually, I've got a 5th there, but the points will clearly go up as the graph goes to the right, because a greater slope is clearly going to give us a greater cart acceleration. There might be some question at this point whether the points ought to be along a straight line or whether the line ought to have some curvature upward. This line, or this data, could actually be interpreted either way. It would be consistent with either assumption. But what we're going to do is we're going to make the assumption that the graph should be linear, and we're going to fit the best straight line we can, the straight line that comes the closest to the points on the average, and we're going to calculate the average, well, the slope of that line. It's just going to have one slope. So we're going to take a line. I didn't do a good job with that line. It doesn't fit the points very well. It could come down a lot lower and get closer on the average. Notice that I don't try to go through any specific point. There's no premium on going through a point, except that, of course, your distance from that point will be 0. But if you don't try to go through points, you can end up getting closer on the average to all the points. So we're going to take the slope of that line and we're going to measure that slope. Now, the cart acceleration is in centimeters per second squared. The ramp slope is a unitless number. You're dividing rise by run, and this is the rise of the ramp and the run of the ramp. And those are both measured in centimeters, and when you divide centimeters by centimeters, you get a unitless quantity. So we see that there's going to be a slope to the graph. It's going to have units of cart acceleration divided by units of ramp slope, but ramp slope has no units, so we're just going to end up with the same units as cart acceleration. So, be clear, there are 2 slopes involved here. There's ramp slope and there's graph slope. Ramp slope is plotted along here. Graph slope is rise divided by run between 2 graph points. So we might make 2 points on this line. Notice I didn't even attempt to use any of the data points because I'm not even trying to go through data points. I can take rise and run. I can divide rise by run between 2 points and obtain the slope of this line. And that's a very significant number if you do this experiment correctly.